All right, so now we're kind of shifting gears again, but this is a very important part of this chapter, and this has to do with what is known as Hess's law. Um, and what this has to do with is the enthalpy of a reaction compared to different parts of a reaction. So it's often possible to calculate delta H for a reaction from the tabulated delta H values of other reactions. If a reaction is carried out in a series of steps, delta H for the reaction will be equal to the sum of the enthalpy changes for the individual steps. Okay, that's kind of a mouthful, but I think we can handle it. Now, what on earth do we do here? So this tells us calculate the delta H for the reaction shown below. S, sulfur, as a solid, plus O2 gas yields SO2 gas. Then we're given two different part reactions. And those two different partial reactions are SO2O2, or sorry, SO2, 2SO2 plus O2 yields 2SO3, and that has a delta H of negative 196 kilojoules. 2SS plus 3O2 yields 2SO3. So I see all of the different components there, but I just don't know what to do with that. So I'm just so confused. I mean, I've got, what, what's that music? That's it. That's it, exactly. Thanks to Missy Misdemeanor Elliott, we know exactly what to do with this example. So we've got an overall reaction right here. And then we have these two different part reactions. I'm going to call them A and B. Now, what you want to do with this, and Missy Elliott tells us this pretty clearly, is that we want to flip it and reverse it. But which reaction do we want to flip and and reverse? Well, let's look at these two different reactions. For reaction A, we've got SO2, O2, and SO3. Now, I want to look at and compare A to my overall reaction up here. Okay, so what are some common features to that? What I see is O2 as a reactant. I'm going to label these reactants and products. Okay, I see O2 as a reactant. I don't see SO3. I see SO2 as a product. Okay, then if I look at reaction B, well, I see sulfur as a reactant, and it's a reactant in reaction B. O2 is also a reactant in reaction B, and SO3, well, SO3 is not there. Okay, so what I want to do is, let's go back. SO3 is not found in either of these two reactions. O2 is found as a reactant, and SO2 is found as a product. So when I look at reactions A and B, I see SO2, but SO2 is only found as a product in my overall reaction. So what I need to do is I need to manipulate these two equations, or reactions A and B, to match my overall reaction. So this is where we get back to Missy Elliott's hit song, Work It, and that is reaction A. We're going to flip that one and reverse it. I'm going to go ahead and do some erasing here so that it's a little bit more clear. So I'm going to rewrite A as 2SO3 gas yields 2SO2 gas plus O2 gas. Now, whenever I do that, well, I've rewritten it, I've considered all of my reactants, all of my products. And what's the great thing about this is my delta H. Do I know my delta H for this opposite reaction? I sure as heck do. It's 196 kilojoules. So I can scribble this one out. So now what I want to do is I want to match up my reactants and my products. So when I look at my flipped and reversed reaction A, which I'm going to write as an upside down letter A, which kind of looks like a V with a line through it there. So my flipped and reversed reaction, I do not need to worry about my original reaction A. What I instead need to do is I need to look at where are my reactants. Okay, so for my flipped reaction A, I've got 2SO3. And what I'm going to do is combine this flipped A and B with one another. Okay, I've got SO3 as a reactant, and lo and behold, in reaction B, I've got 2SO3 as a product. So what do you know? Those two are going to cancel out. So what are going to be the remaining reactants? Well, whenever I combine flipped A and B, I've got two S, solid, plus 3 O2, gas, yields, okay, now what are my products? My only products are 2 SO2 plus O2. Okay, now I'm going to go ahead and write my states down there, gas and gas. If something is found on the reactant side and the product side, I can basically ignore that. I've got 1 O2 left over on a product, so I'm going to erase that one, and I'm going to subtract that 1 from my 3, so now I've got 2 O2. So now what I've got is 2S plus 2 O2 yields 2 SO2. Well, I could reduce that one down so that it is ultimately, well, it's going to be basically the same as my overall reaction. But before I do that, I want to combine my delta H's. My delta H for these two reactions are 196 and negative 790. So when I combine those two, what I'm looking at is something that ultimately is delta H is equal to negative. Now,